Hi stats class, welcome to a little practice with z-scores and percentiles. Just as a quick refresher, remember that z-scores are the distance that a data point lies away from the mean in terms of standard deviations. This would be like measuring how far you live away from school in terms of tractor trailers or football fields instead of miles or kilometers. It's just a different way to measure. It's in reference to something else. Percentiles, remember, if you're in the 84th percentile for cholesterol levels for your age group, this is not a good thing because that means that 84% of the population tested for cholesterol levels in your age group had a lower cholesterol level than you. Keep those in mind as we answer these questions. You will also need to open a Fathom document that's titled Unemployment Rates by State and order the table smallest to biggest. To do that, go ahead and click on the column that has the percent of population, percent of unemployment in it. Right click or control click and you'll end up with some choices. Choose sort ascending. That'll mean that your data will be sorted smallest to biggest. Once you have your data sorted, give these two questions a try. Press pause and I'll answer them in a moment. What percentile Illinois lies in? Well, we need to count how many states have a lower percent of unemployment than Illinois. It turns out that there are 39 states with a lower percent of unemployment than Illinois. 39 divided by 50 will give us our percentile because 50 is the total amount of states, and we end up with a 78th percentile. There are 78% of the states that have a lower unemployment rate than Illinois. Which state is in the 40th percentile? So I'm just going to do the work I just did sort of backwards. I'm going to take my percentage of 50. So 40% of 50 will tell me how many states need to lie below the state we're looking for, the unemployment rate we're looking for. So there will be 20 states below. So I'm looking in my data table for the 21st data entry. And that is 5.2%, Louisiana, Massachusetts, Vermont, and somebody over here, Colorado. All have 5.2% unemployment rates in 2008, and so that means that they all lie in the 40th percentile because 40% of the population has a lower unemployment rate than they do. Unemployment, once again, sorry for the stray markings, in December of 2000, so this is earlier, prior to the data table we just saw. It gives you some information here about unemployment rate in terms of standard deviation for that month and the mean for that month, as well as Illinois' particular unemployment rate and how many states had a lower unemployment than Illinois. Read through the given information and the three questions, give them a try on your own, and I will have the answers shortly. Press pause. So writing a sentence to compare the actual rates, clearly right here, Illinois had a lower unemployment rate in 2000 than it did in 2008. 2008's unemployment rate, remember, was 6.9. So clearly lower. Comparing percentiles, as we recall from the problem we just did earlier, we were in the 78th percentile in 2008. But here, if there are 42 states with a lower unemployment rate than Illinois in 2000, 42 out of 50, that's an unemployment rate of 84%. So in 2000, the unemployment rate was in the 84th percentile, which means 84% of the states had a lower unemployment than Illinois in 2000. Standard deviation I gave here for 2008 as well as the mean for 2008 so that you could compare z-scores. You should have calculated z-scores like this. This is the z-score for 2000 and the z-score for 2008. We noticed that the z-score for 2000 was much bigger than, not much bigger, but a little bit bigger than the z-score for 2008. Notice that the standard deviation in 2008 is much bigger than the standard deviation in 2000. The small standard deviation, or relative small standard deviation in 2000 tells me that my data points in 2000 are closer together, and that's why 4.5 is more standard deviations away than 6.9 was in 2008. So my 2000 unemployment rate is further from the mean. My standard deviation is pretty small. So in 2000, all of the unemployment rates must have been fairly close together in order for 4.5 to be a little further away from the mean than 6.9 was in 2008. And we can see that by this standard deviation. My standard deviation is 1.39%, almost 1.4%, a distance between any given point and the mean. So we're closer to our mean by standard deviations, but remember our standard deviation is bigger. So does that explain stuff a little bit? Okay, so quick recap. This small standard deviation tells me that in December of 2000, my unemployment rates were fairly close together. This standard deviation that's bigger tells me that in 2008, my unemployment rates were further apart. So my z-scores here tell me, based on the standard deviation, I'm further away. Based on the standard deviation, I'm a little closer for Illinois. But what's really telling is the standard deviation and the mean. In 2008, clearly something was very different. As we all know, there was an economic crisis. My average unemployment rate is much higher. My standard deviation is much higher. So things are all out of whack in 2008. I hope that helped a little bit. Moving forward. So now a little bit more about heights. I've got some given information here. I want you to use that given information and answer questions A, B, C, and D. A and B are very similar to C and D. If you get stuck with A and B, press play again and then listen to the explanation, and then press pause once more to try C and D on your own, having had the explanation. So go ahead and press pause. Finding the mean and standard deviation for males, for 15-year-old males. So using the given information, we can see that a z-score of 0 was for a height of 170. If the z-score is 0, that means that it is 0 standard deviations away from the mean, which must mean that 170 is our mean. A z-score of 1 tells me that we are 1 standard deviation away from the mean, so 177.5 centimeters is 1 standard deviation away from my mean of 170. Therefore, I can calculate the standard deviation simply by subtracting. So my standard deviation is 7.5 centimeters. What height would have a z-score of 2.5? I'm just going to calculate z-score backwards. I have z-score, I want the height. So you can use your equation and then just solve for the data point, or you can think about it as I have 2.5 standard deviations. Okay, well, a standard deviation is 7.5. So that means 18.75 centimeters from the mean. And I know the mean. The mean is 170 centimeters. So I added the extra height. I added it because the z-score was positive. So I have a boy who is 188.75 centimeters tall. Use this same idea from parts A and B to help you with parts C and D. There's just different given information. Press pause again if you haven't completed them. So like I said, these are very similar. And if the z-score was 0 at a height of 162.5 centimeters, that is the mean. If a standard deviation, one standard deviation, was 162.5 centimeters, 169 centimeters, then that distance from the mean of 162.5 is the standard deviation. If I have a z-score that's negative, I know that the girl is shorter than the mean. So she's going to be shorter than 162.5 centimeters. I'm going to keep that in the back of my head. She is 1.5 standard deviations away. I know the standard deviation is 6.5. 1.5 of those is a total of 9.75 centimeters. Remember, she's shorter than the mean. So I took the mean and subtracted her height, subtracted the 9.75, the 1.5 standard deviations, and that does give me the girl's height. So again, I took the mean, I subtracted the 1.5 standard deviations, and I got her height. Normal distributions. This is what we started talking about in class on Friday. A normal distribution, if we normalize a set of data, what we're doing is we're drawing this nice curve over a histogram or a dot plot that has very narrow width bins. And it's idealized in that it's really just an approximation of the curve. Secondly, we're going to rescale it. This kind of curve happens if our median and mean are exactly the same, if they're the same. We're going to call this place where the median and mean would occur. This is our balance point, as well as where half of the data lie above and below, cuts our data area in half. So I'm going to call that 0. That's a z-score of 0. So what I'm doing is I'm relabeling the axes, the x-axis, with z-scores. 1, 2, 3. So this means I'm 1 standard deviation away. At this point on the curve, I would be 2 standard deviations away. At this point on the curve, I would be 3 standard deviations away. Similarly for the negative side. If we go less than the mean, we have a negative z-score. -1 standard deviation, -2 standard deviations, -3 standard deviations. So anywhere along this axis, I could draw a point, and that would be how many standard deviations I am away from the mean. So at this particular point on the curve, right here, I would be approximately half of a standard deviation away from the mean. And that would mean that I have a little more than half of the data points below me, because a little more than half of the area of the graph is included from this red line to the left. Okay? The scale is created so that the area under here, so if I were to put in a y-axis, the area under this graph is 1, exactly. So when we normalize the curve, we can talk about area under the curve relating to our z-score, which also relates to a percentage of population that is below that z-score. So whatever percentage of area I have here, that's the percentage of people who have a value less than this particular value in my data point, my data set. Why do we do this? Well, we want to make a connection between the z-score, which tells how many standard deviations a point is away from the mean, and area under the curve, and percentiles. It just makes it a little easier if we put all those things together to talk about where a data point lies in the data set. It's very visual, it's standardized, so it's always the same no matter what particular data set you're talking about. If I said that I lie 1 standard deviation away, everybody would know that I'm talking about the 84th percentile. So it just makes it something that we can talk about for any data set. So again, remember we're talking about z-score is the x-axis there, and that's the amount of standard deviations away from the mean. And it's going to show area as well as proportion of area. Whoops, that should say proportion, not portion. Proportion of area, so that we can talk about percentiles a little bit more easily. From one data set to the next, it'll all be relatively the same. Remember the problem we just did with heights? So we're going to use our idea of percentile, z-score, and this normalized curve to help answer a question. If we were to normalize a curve for the data about heights in problem number 3 earlier, we would see that a z-score of 0 shows that 50% of the 15-year-old boys are shorter than that boy with that z-score, because a z-score of 0 is right here, and that's right in the middle. That is our mean. So a z-score of 0 is our mean. A boy whose height is 162.5 centimeters has a z-score of -1 based on the earlier problem. Go ahead and draw a vertical line like I did for a z-score of 0 for that particular z-score. Looking at the graph, what percentile does that boy in? To answer this, what you're going to do is look and see what percentage of area seems to be to the left of that -1. And again, it's a freehand drawing, so it's not going to be perfect, but just an estimate. Press pause and give it a try. So the area that is to the left here, it looks like it's less than 25%. It is actually 32%. So if you said 25, 20%, you're on the right track. It's a fairly small percentage. The amount of area that lies between -1, a z-score of -1, and a z-score of 1 is 68%. And that's how I know that there's 32% left over, because 68 plus 64 is not 100. Hang on, restart. Sorry about that. It's not 32% left over. 32% is both tails, so we really only have 16%. So if you said 25% or 20%, you're very close. It's actually 16%. Sorry about that. Hope you're having a great snow day. Please complete the homework